Okay, first of all, if you have been given a question like this, given the value of x is equals to 3 cos t, y is equals to 3 sin t, and z is equals to 4t, and you'll be given, in the first, one of the questions is find the unit tangent vector t. Last time, we spoke about the three-plane figure of the x, y, and z plane. And these are, if you want to write in the three-plane figure, the r is always xi plus yz plus yj plus zk. Now, the x have been given as 3 cos t, y is 3 sin t, and z is 4t. Substituting them in this question, I'll have my r to be 3 cos ti plus 3 sin tj plus 4tk. Now, finding t, this vector t is equals to d of r over d of s. But if I want to find d of r over d of x, I can't use this equation directly, because if I differentiate this equation, I'm differentiating with respect to t. So I must find d of r over d of t. Then I find d of t over d of s. This one I'll be using the formula known as the chain rule differentiation, the first calculus one. Now, the r over dt, from the value of r here, I'll differentiate 3 cos t. And differentiating cos t, I'll have negative sin t. So my answer will be negative 3 sin ti. Differentiating sin, I'll get cos. I'll have plus 3 cos tj. And differentiating 4t, I'll have 4 as the constant. That is 4k. That is my d of r over d of t. Now, to find this dt over ds, I'll use this formula. If you want to find ds over dt, is always the magnitude of the r over the dt. The magnitude of the modulus, the s over dt, is the magnitude of the r over dt. Now, this the r over dt, I'm having the r over dt. I'm having the r over dt here. If I find the magnitude, I'll have the square root of negative 3 sin t. I'll have 9 sin squared t. 3 cos t, I'll have plus 3 cos squared t, then plus 16. That is my value. Not 3 here, it is 9. That is my value of the r over dt, the modulus. Now, finding the square root of this function, I can factor out sin squared t plus cos squared t here outside. I'll have the square root of 9 into sin squared t plus cos squared t. Then I close the bracket plus 16. It is still under the square root. From the identity, sin squared t plus cos squared t, I'll have 1. Now, if I substitute this square root, I'll have my value as the square root of 9 multiplied by 1 plus 16. Of which this will be the square root of 25. Then my value of the s over dt will be 5. Now, the s over dt is equals to 5. Let me come back to the value of t. I was looking at the value of t. T was equals to the r over the s, which is equals to, using the formula of chain rule, the r over dt multiplied by dt over ds. Now, the r over dt, I'm having it here. Negative 3 sin ti plus 3 cos tj, then plus 4k. I multiply it with dt over ds, but I'm having here ds over dt. Now, dt over ds, it is the inverse of this one, 1 over. Now, multiplied by 1 over 5. Now, my value of t will be equals to negative 3 over 5 sin ti plus 3 over 5 cos tj plus 4 over 5k. That's my value of t. And I'm done with the question A. Question B, we are being told to find the principal normal n. B, principal normal n. Principal normal n, from the first frenet-serret formula, we are told that d of d over d of s is equals to kn. I'm only having not d of d, it is d of t. D of t over d of s is equals to kn. I'm already having d of t. I'm having it here. I can find dt over ds. I'm already having k. Okay, k, you can find it from this formula. So I can say that d of t over d of s is equals to d of t over d of t, the small t, multiplied by d of t over d of s. And dt over dt, I differentiate from the value of t. I can have negative 3 over 5 sin t. If I differentiate sin t, I get cos t. Now I have negative 3 over 5 cos t I. 3 over 5 cos tj. If I differentiate cos, I get negative sin. So now I have negative 3 over 5 sin tj. These are constant. If I differentiate constant, I get 0. Now this is the value of dt over dt. Multiply by dt over ds. I already have ds over dt. Now dt over ds is the inverse of this one. Now I'll have to multiply. If I want to get dt over ds, I'll use the chain rule of dt over d of the small t multiplied by d of the small t over ds. This will give me negative 3 over 5 cos ti minus 3 over 5 sin tj multiplied by 1 over 5. Now my value of dt over ds will be equals to negative 3 over 25 cos ti minus 3 over 25 sin tj. Yeah, this is my answer of dt over ds. But I was looking at the principal normal n. Now, this dt over ds, I can first find the value of k. And k is equals to the magnitude of dt over ds. The magnitude. Now, the modulus of dt over ds, I'll find the square root of this one square. Now this will be k is equal to the square root of 9 over 6 25 cos square t plus 9 over 6 25 sin square t. I'm having a common constant, yes, 9 over 6 25, 9 over 6 25. I can factor it outside. I'll have 9 over 6 25 into cos square t plus sin square t. Everything under the root. But from the identity, cos square t plus sin square t is equals to 1. Now I'll remain with the square root of 9 over 6 25 as the value of k. If I find the square root, I have the value of k as 3 over 25. I'm having the value of k, I'm having the value of ds over dt. Now I can find the value of normal. And we're told that from the first frenet-serret question, this is the first frenet-serret question. I'm having the value of k, I'm having the value of ds over dt. I can find the value of n. So I'll use this formula. N is equals to 1 over k into d of s, d of t over d of s. Using this formula, 1 over k, it is the inverse of the value of k. Now I'll have 25 over 3. This will be 25 over 3 into dt over ds. dt over ds was negative 3 over 25 cos ti minus 3 over 25 sin t j. But this 3 over 25 is a common divisor in the equation. Now I can cancel this 25 goes with these 25s and this 3 goes with this 3. Now it remains with n is equals to negative cos ti minus sin tj. Now this is the value of n, our principal normal n. We're done with the question B. Okay, let's go to part C. Part C, we have been told that find the curvature, not the curvature, find the normal, the binomial B. Part C, find the binomial B. And from that graph, that small graph of the plane figure, I'm having this as the x-axis, these are the y-axis, these are the z-axis. Then this is my curve. I'm looking at the tangent at the gradient at this point. So I'll have to look at the tangent t. This is my vector of the tangent t. The normal, it is always perpendicular to the tangent. This is my normal. And the binomial is always perpendicular to both of the two planes. This is my binomial. Now, if I want to find this binomial, I'll use the cross product of this tangent multiplied by the normal. Last class, we said that if we use the anti-clockwise direction, we always have positive values. But if we use the clockwise direction, we always have negative values. Now, for I to get this positive b, binomial b, I'll use the tangent t cross multiply with the normal n. And my tangent, I had my tangent as negative 3 over 5 cos ti plus 3 over 5, this is 3 over 5 sin ti plus 3 over 5 cos tj plus 4 over 5k. This was my tangent t. And my normal n, I had my normal n as negative cos ti minus sin tj. Here's my normal. Now, for I to get this binomial, I have to cross multiply the two. Cross multiplying the two, I'll use this formula. I, j, k, that's the formula for cross product. Then I take the value of the tangent, that is negative 3 over 5 sin t, 3 over 5 positive cos t, and 4 over 5. And 4 over 5 is the constant. Then the value of m, I'm having negative cos t, negative sin t. I don't have the value of z-axis. Now it will be 0. If I want to find the value of j, of I, I'll close this column and this row, and I'll have I into 3 over 5 times 0. I'll have 0 minus. This one and this one, I'll have it as negative 4 over 5 sin t. That's my I. Then I negate j into. I close this row and this column. I'll have this times this as 0. The leading diagonal is 0. The other diagonal, it is negative 4 over 5 cos t. That's my j. Then we add to k. The value of k, I'll close this column and this row. I'll have this times this. These are negative. I'll have positive 3 over 5 sin squared t minus these and these. I'll have negative 3 over 5 cos squared t. That is my k. Negative and negative gives me a positive. I'll have positive 4 over 5 sin t Negative negative gives me a positive, and then the negative 4 over 5 cos tj, then plus negative and negative gives me a positive, and I'll factor out 3 over 5 because it's a common. I'll have 3 over 5 into cos squared t plus sine squared t. Everything is with k. Cos squared t plus sine squared t, I'm having an identity which is equals to 1. Now this value, all of it, and equate it to 1. Now my final answer will be 4 over 5 sine t minus 4 over 5 cos tj plus 3 over 5 k. This is my value of binomial b. And we are done. Now the last part of the question is finding the torsion. And from the formula, we have been told that torsion is equal to the magnitude of dB over d of s. I'm already having my value of b here. I can find dB over ds, but I'm having dB with respect to t. Now first of all, I have to find d of b over d of t, which will be, if I differentiate this one, 4 over 5 sine t. Sine into cos gives me a positive. I'll have 4 over 5 cos t I. Cos, I want to differentiate it to get from 4 over 5 cos t. I'll have negative, which is negatives. I have 4 over 5 sine tj. And the 3 over 5, that is a constant. If I differentiate, I get 0. Now this is my value. I'll have dB over dt as 4 over 5 cos ti plus 4 over 5 sine tj. That's my value of dB over dt. But I was looking at dB over ds. For I to get dB over ds, I have to apply chain rule, which I'll use dB over dt multiplied by dt over ds. And this one I'll have 4 over 5 cos ti plus 4 over 5 sine tj. I multiply with dt over ds, which I had earlier as ds over dt, which is 5. That means dt over ds will be equals to 1 over 5. Now I'll multiply here by 1 over 5. Now my dB over ds will be equals to 4 over 25 cos ti plus 4 over 25 sine tj. That's my dB over ds. But I was looking at the torsion, and you're told that the torsion is equals to magnitude of dB over ds. Now I have to look at the magnitude of this one so that I can get the torsion. Torsion will be equals to the magnitude of this one, which is 16 over 625 cos square t plus 16 over 625 sine squared t. Let me use this next. Now, my torsion will be, I can factor out 16 over 625, the square root of 16 over 625 into cos square t plus sine square t. And this one from the identity, cos square t plus sine square t is equals to 1. Now I can have my torsion as the square root of 16 over 625, which will be equals to 4 over 25.